Good morning, everyone. Who did notice that this is a workshop? Good. Okay, let me get the clicker. So we meet together to do a workshop together. If you do not have your laptop, you will still benefit some sort, but not the full extent because you will lack the hands-on part that you can participate. Everything is on GitHub, so if you want to do it later at your company when you are back home, that's all good. But here you can ask questions. The presentation itself will be short. I will give a quick intro about myself, the idea behind it, and then we go into the workshop. You can deploy it into your own accounts, ask questions, present even your screen if you want to have the discussion with everyone. So, shall we start? So my name is Frank Dornberger. I came over from Hamburg in Germany. I work for a startup called movingimage. We're a video management platform. Before I joined about a year ago, I was a solution engineer at Relic, where I developed the idea that we go through. I tried to implement it with 2 customers, but none wanted to speak about it. So they asked me to come here today so I speak personally about it. Just to recap the prerequisites, if you want to do the workshop later on in this session, you would need a new Relic account where you can deploy the dashboard that we're going to build. You need a personal API key to access the API to upload the dashboard. You will have a Kubernetes cluster, hopefully with data in that account, so the dashboard can show things to you. And you will need Terraform at least version 1.0 to use the code that I prepared. If you do not have that, please try to complete it in the next few minutes so you're ready to go when we do the hands-on part. Some brief history of humankind and machines. So we came historically with bare metal machines, and at one point, if you're not running a mainframe or anything, you figured out that the machine is too powerful for the workload to fully fill a machine. So we came up with concepts like virtual machines to better use the power of the hardware that we have bought for expensive money in our companies. Now, in a modern software architecture where we have microservices, even a virtual machine can be too huge in terms of the power that it has to really make good use of the resources that we have available. So we came up with a new concept, which is the container. But the container still has, let's say, a possibility to over-provision and to have too much power available, and we don't know what the future will hold. Maybe, there's the next thing that is even smaller than container. We already have functions that we can expose as serverless, but maybe not even that is the end of the journey. So basically, what I was speaking about, if you have a container, and picture this thing just as being your container, you have the resource that is required to do your workload, and then you have the overhead, which is simply a waste. So it is still possible, although we run in containers, that we use more infrastructure and pay for it, especially in an expensive cloud environment, that we're actually making good use of. Questions so far? Okay. So this is a bit of the mechanic on how Kubernetes works behind the scene. You can or you cannot define resource requests and limitations. Is anyone aware what request and limit do mean? Okay, I see some noddings.
Yeah, it's like in the general way, we can say like minimum and max limit.
Mm-hmm.
We are defining for the.
Yeah, so that's true. So request is hardwired to your container. No one else can have it. Limit is like at best will, you can go there, but if, let's say your workload runs, I have been told there is some sort of a pointer, if your workload runs only like low in this part or low in this part, even the request is way too high. And this is something that, especially when software engineers are given the ability or even are required to run their stack in Kubernetes and they have no clue about the footprint of their applications, they tend to do, let's take at least a core. And maybe it runs on 10 millicores or something like that. So you may largely over-provision your container just because the engineers have no clue what is a realistic use of either CPU or memory. And this is something that I thought may have happened in our company, so I basically ran that concept as a test to see how large is the over-provisioning in our company, and after we ran through the entire stack, we shrank our Kubernetes production cluster by 50% and the non-production ones even by 60%. So there's a huge savings opportunity just by making sure our containers are not overblown, but still trying to have a safe environment for our applications to be. And in a few instances, we even gave more resources to the application, so they started to have less restarts or being fewer throttled, which is happening when you hit the limits. If you hit the memory limit, your container will just be killed and restarted, which can be bad for the payload that is currently executed on it. And if you hit the CPU limit, your payload is being basically like if you hit the brake on your car. It's not a smooth way of dealing with your application. So the goal was obviously to drive costs down and performance up. In the example in my company, we mainly drove costs down. Performance was already mainly good. We had a few applications where we allocated more resources and we saw that they were working better afterwards, but we shrank down, as just mentioned, production by 50 and non-production by 60%. Questions? Okay. Then here's the hands-on part. If you go there, you will end up in a GitHub repository where you find an instruction on how to deploy the dashboard. Let me open that as well. Oops. It's not visible anymore. How do I show this one? Just showing the background. Move it to one side or another.
Oh, you don't want to put it over there?
Yeah.
Okay, so to do it like...
Oh, there's coming.
Yeah.
Yeah.
No problem.
Oh, cool, thank you. Okay, so let's see if I can still navigate this thing. So there is a brief introduction, the requirements again, and then a quick setup. How you basically make it work. You need just a few variables to provide. I assume that most of you have their accounts in the US region. Good point, thank you. Is this readable? Okay, thank you. Thanks for the hint. So the variables you need to provide as either environment variables or by putting it in the variables file as described is your Relic account number and your personal API key. The zone can be set should you not be in the US like it's happening in my case. My account is in the European data center, but the US is the default behavior. Let's see. So this is basically what I just tried to say. And then is anyone not familiar with Terraform in here? Okay, that's a good thing. Where's my mouse? Pardon? So the URL is, if you go to, let's go back into presentation mode. If you go here, it will bring you to the GitHub repository. Okay. Everyone is fine with the URL? Okay. Switch over here. Okay. I'll give you a couple of minutes to do the config of the text file, but I'll show you also where this can be done. Is it this side? Yes. So if you make that a bit larger. So this is an example of the config file that you can use. Just replace the examples.tfvars by, what was it again? Terraform.tfvars, and then it will be picked up automatically by Terraform if you do a plan or an apply later. And basically replace the upper two values by what is specific for your account. I'll give you a quick explanation on the other ones that you can configure. This is basically to make sure it's relevant for your company. The values that you have basically down here is how much wiggle room you want to give your application within the container sizes as a safety net. So if we focus on the three CPU-related values, the request margin is basically the CPU amount that we observe, plus in this case 50% would be your request, and the limit would be plus 100%. The CPU threshold is, in this case, the 95th percentile, meaning the top 5% in CPU usage, and the same configuration is for memory. If you want to have higher values or lower values, you can adjust them and the dashboard will work accordingly. Was someone already able to create a dashboard?
Yes.
Cool. Is 5 more minutes good for everyone to try to come up with the dashboard? Okay. I'll just switch over to my console so you can see how this can look like. Where's my mouse?
Thanks for the dashboard.
You're welcome. Make it a bit larger. So if you do a Terraform plan, this is something that you should get as an output. It shows you basically the dashboard to create. And if we look here, you will see some of those numbers that we have set just in here. So it picks it up based on your config file. So if you want, instead of the 95th percentile, you want the 98 or you want the 50th or whatever it is, the dashboard will pick it up. If we create this one, so it asks you if you should actually create it. You can confirm. If there is an internet connection, it will create it for you. Let's see, where's my mouse cursor? You will even get a handy URL at the end of it. And if you open this one, it will open up the dashboard for you. Let's see. Yes, it does. Is this somewhat readable? More or less. Yes. So the top line is basically a selector for making the dashboard more relevant. I'm a big fan of, let's say, multi-purpose dashboards, which looking at them is completely irrelevant. But as soon as you do a filter or two, they become super specific to a use case. And this is one of those dashboards. So if you look here, the very top left one is choose your cluster. So you can make a selection by clicking on it. And so this is actually our production environment. So if you see here, you have a little filter icon. You can click on it, and then you're now filtering it only to, in this case, it's our production cluster. Next to it, you can select a namespace. So here you have your namespaces, of which you can select one. And I'll just pick the first one to show again. You see you have a little funnel icon here. You click on it, and then it's filtering down now to the cluster that you have chosen and the namespace that you have chosen. The little funnel icons that you have here is not the only way how to filter it. You can also go here and do the filters for yourself. This can come in handy, for instance, if later on you want to export a list that we have at the very bottom of the dashboard, and for instance, you're in charge of like 5 or 6 namespaces in a given cluster, or you're in charge of 3 or 4 clusters, and you want to basically export the raw values for a Jira ticket or something like that. So you can manually adjust your filters up here and do list filters as well instead of just single values. Now, the last selection that you can do is actually take one of your payloads here to make it very specific, the rest of the analysis of the dashboard. Now, I just picked a random one. I don't even know if it's a good example, but we'll figure it out together. What you will see here in the dashboard is, at first, in the very left-hand side is the current configuration of your payload. And if there is not 4 values showing up, it means you have not defined all of them. This can happen at times if your deployments do not even have specific values, that they are blank. Now, the suggested ones that you see next to it, like here, is based on the calculation that we just did. What is in my case, the 95th percentile plus 50% margin for request plus 100% margin for limits. These are the values that come out right there. Next to it is something like a counter indicator why you may not want to do that. And if we have a high number of throttles, and that depends a bit on how many copies you have in there. If you have 50,000 copies of something, 100 throttles per time interval is neglectable. If, on the other hand, you have 2 copies and you see 2,000 throttles, maybe not the best move to make. Further down, we have the same here with the memory part. If we have a lot of out-of-memory killed events recorded in your Relic, maybe not give it less memory, because you would just further increase the pressure to your application. And then what you see here as well is the potential savings that you would get out of applying those changes. So in this example, you can see we have here one payload that has a CPU limit of 4, and applying the 0.8 rounded up that we see here, you would reduce the limit by about 3.2 cores. A set limit is just the best effort, like the stretching zone that you potentially give to your application. So this is not a guaranteed saving. It is just making sure that your application is not consuming too much eventually or leaving leeway for other applications. Pardon? So the suggestion comes from, where do we have it? Where's my visual code? Here, based on these settings. So if we go back, we took the 95th percentile of the current consumption based on the last week. So it takes the last 7 days, and the same for memory. And then it puts 50% as the wiggle room for application, because what you don't want to have is your production suffers just for cost optimization. This makes no sense. So the safety net that I applied is 50%. If you run at, let's say, 100 millicores, it would suggest 150 for the request, and it would suggest 200 for the limit for CPU.
Because we have actually implemented VPA
Mm-hmm.
to do that.
Yep. Yeah. So VPA is fine if your application can be restarted. If, on the other hand, because the container needs to be restarted. If your container should not be restarted, or because VPA still needs, let's say, meaningful values. If you have this CPU footprint that you actually use, but you give it that much, and from memory you have a closer ratio, VPA has a hard time to balance those things. So to baseline, this may still be helpful. Let's go further down. What do we have down here? You have just a few more graphs that help you indicate how is the footprint of your application, just to see, does the change that I want to make, does it have sense? I give you a few examples why some of the things that you see could be difficult. Java is a typical use case because the JVM is quite memory sucky. So it could indicate that you have to add more memory, and then it gets the whole memory again, and then it adds more memory again. So you may end up in an infinite loop of just allocating more memory. Another use case that we came across when we applied this was also with Java, and it's putting anything below 1 core for Java applications just led for applications to boot up in like 40, 50 seconds. How we solved it is we just put the limit to at least 1 core. So the boot up time consumes a bit more CPU, and then it goes back to a meaningful request amount. But it needed a bit of back and forth with New Relic support to figure out why our application suddenly took almost a minute to start. Just, as I said, before you run it in production, try it in a non-production environment. Cost saving is something that your company will love you for, but not if you create outages. So if we have some PMs in here, or people that tend to create backlog tickets for their teams, the last one can be quite handy because it helps you export all the raw values that you can later create tickets for, or take the values for your deployment YAMLs as a working item. So as the description indicates, if you go to the very end, there's an export functionality where I can hardly see. One of those says export as CSV. And then you get a CSV file that you can just add to a Jira ticket. Now, since we have narrowed our dashboard to just a single container, it will give a one-line item. But if we go further up again, oops, here, and we take, for instance, all of production, the list is supposed to grow, but maybe I did have to refresh. Okay. Yes, there is a larger list. So this is how we managed our backlog, which is made CSVs that are specific to individual teams. And here's your backlog item, please work on it. If you have any questions very specific to your cluster, you can bring your dashboards to the screen and we can discuss it. This is an option. Otherwise, I saw you have a question.
So does this have VPA pre-installed?
No, no VPA on it.
It doesn't make any recommendations or anything as such on this dashboard?
So what is installed is basically just the standard New Relic monitoring for Kubernetes. It requires the daemon set and the metric server. That's it. The dashboard is pure visualization. And then you can take the CSV at the end for your backlog management or something like that. Yeah. VPA is definitely an option. That, as I mentioned before, if you have odd ratios between the CPU footprint and the memory footprint, VPA will struggle to make sane recommendations just because it's hard for it. But VPA is an option, especially when your application can be restarted. If you have applications that suffer, though, from being restarted often, maybe this is a better approach.
Actually, laptop is not, it's like that. So this Terraform 5 is actually like a GitHub site? Like
Yep.
the URL which
Mm-hmm. Exactly. Yeah.
I wanted to try that option.
Do you want to present? If you have Zoom installed on your machine, you can put your screen up.
I mean, my laptop is like 4%.
Oh, okay. Yeah.
That's why.
Yeah. Would anyone else like to throw a question on the screen that we can discuss?
Yeah, I have some questions about the memory recommendations.
Uh-huh.
I have Zoom. What I have to do?
So you basically go, where's the mouse when it comes back? So you can go here. And then we can bring up your Zoom. Oh, let's see, no. It's not presenting, so let me see. I probably have to move that over. So it's, which one is the presenting one? I think this one here. Yes, so. Oh. So, Yeah.
So I also just did it to 60 minutes just to make it smaller.
Yeah.
So I note that it wants us to increase the memory, both request and limit.
Yeah.
But looking here, there's been 0 OM fills, and looking at the memory usage per container, like this highest one is 700. So I'm wondering, like, if the highest one is 700, why is it suggesting that I request a higher number than that?
Yeah. It's based on the safety margin that is in the config file. So the average consumption is basically a third less than the 1,000, you know, the plus 50%. So if you take a third away, it's around 700-ish that we seem to see as the consumption, and the 50% margin on top of it leads to the 1,000. It is just to have some safety for production, because as said, saving money is great, but not if production goes down for it.
I see. So adjusting these margins would
Yeah, yeah. If you're fine with, let's say, just 20% overhead free, because you know memory never changes much, some of our applications, they have a very strong changing memory footprint, and therefore we want, production cannot go down for that. If you know your memory footprint doesn't vary so much, you can go down and say, you know what, I don't need a gigabyte of memory, I'm fine with 800 or 700. Yeah.
And I guess just to make sure I understand the behavior CPU limiting properly.
Yep.
These CPU throttle lines, if I made the CPU limit to some ridiculously high number, this chart would go down.
Yeah. I can guarantee that it goes down to 0, because you know you may still have CPU spikes for a few milliseconds, and then you have a throttle. But and limit is always best effort if the cluster has resources to allocate. So if you put your request at an insanely high number, then you would see the throttles going down.
Okay. Yes.
Okay. Anyone else having questions? Sure.
I have a lot of Java workflows that talk about when looking at the memory composition. Those are things that you look at. Something I've been trying to look into is that there's a lot of on the APM side of the metrics on like just JVM sizing pieces.
Yep.
Is that something you can consider as well?
So the JVM metrics are a bit harder to include into all of that because of, you know, it's completely different entities, but what we told our Java teams as well, if it seems to suggest increase your memory by literally 100%, or you know something that just seems not making any sense, look at your JVM metrics as well to see the consumption in there. But yes, very good point. JVM metrics is something, especially if you run a lot of Java, have a look at it before you're increasing your cluster just because you think your application will get better. But what you can have a look as well is like the out-of-memory kills. If you have 0, it doesn't make sense to increase the memory by an insane amount. Does that help?
Yes.
Okay.
I'm curious if maybe one follow-up on that. I know there's a couple examples of how this compute, like what that native memory need is mode in like thread and reallocation for recursive. Was there any methods and did you give guidance to teams that here's what heap size is needed as well as it gets complicated?
Yeah. I never wrote in Java, so the Java optimization thing, I'm just not an expert in it. Yeah. Unfortunately.
Thanks for that.
You're welcome. Other questions? Yes.
To your point, that is something we're starting to tackle because our memory usage is through the roof on Java, and everybody is like, well, we need more, and Java says we need more. And it's like we've been working on getting the JMX in and then exporting the memory metrics so that we can analyze it better because you can't really see it just from what Kubernetes shows since it's a virtual machine and a virtual machine. Right. Which is a nightmare.
Yeah.
Yeah, it's a pain. Yeah.
Unfortunately, it is, yes. That's why I said be a bit careful, especially when you run a lot of Java. With memory, it can look a bit strange. And based on how maybe just an explanation on why the one core limit for Java helped us deal with the problem. What's the underlying issue is, the more libraries you pull in into Java, the more the New Relic agent has to do at the boot up time. What it's basically doing is they read the entire library, they inject their New Relic magic into it, and then they have a modified library that they use at runtime. And that takes time. Especially if you have complex libraries or many of them, they need to read them all into the code injection, and that's happening at boot up time. The Java agent was designed and architected when Kubernetes and containers was not a thing, and we had virtual machines where no virtual machine was running at half a core. So boot up time was not a thing that they needed to worry about. And now in the containerized world, the agent still functions the same way, but that means that if you want to give your application half a core, it takes 40 seconds to boot. Do we have more questions? See? Oh, we're pretty fast on time. I don't have any more to show. It is a fairly simple principle. It can save a company a tremendous amount of money. It can help you stabilize your production, especially if you have performance issues and you under-allocated memories and you do not have something like horizontal pod autoscaler or virtual pod autoscaler, but you have a fairly static thing. In some cases, scaling is also not an option, like message queues tend to die after a certain amount of replications. You cannot outscale it with adding 50 replications of a RabbitMQ. The queue is just dead. So getting it enough and meaningful resources does help, but as said, if you save your company money, it's the next company event, it's the next raise, it's the next funding round that is getting easier, or whatever it is, or at least you get a pat on your shoulder. That's it. If you have no more questions, that was the content of the workshop. I can, again, should you ever have questions, you can feel free to reach out. Hey, I ran into this something. Could you help me make sense of it? And I'll give it a try. Yes, sure.
Contributing back to kind of name this as Feature Stack 2022 workshop. Is this dashboard, we want to make changes, just go to this repo to pull?
Yes, exactly. Yeah. It's there. I actually had, and that was interesting, so this is joined to the blog article that New Relic and movingimage has done. And as a preparation of the workshop, I posted it on GitHub so everyone could easily access it. And I think a day after I published it, no one has ever contributed to anything in my personal repo. And someone came in and said, hey, I have a recommendation how you could make something better, and closed it right after and said I was wrong. And I was looking at it, I was like, no, you were right. So I implemented the change, actually. And the change came from the New Relic forum. So someone asked if the dashboard that was referred to in the blog article was accessible somewhere, did the research, found the repository, linked it back in the forum, and since then I have traffic on this dashboard. So yes, if you see changes, feel free to contribute. I will review. And if I find it's something that I would see as beneficial, I will gladly accept. Okay. Thanks for participating. I hope it was good. Pardon? Oh, sure. So where do we have it? So this is just the config file itself, where the magic is happening. So first you have the provider configuration, like I need the New Relic thing. And then here's the dashboard itself, where everything is configured. Yeah. You can change the layouts, the queries in it, if you want to understand what it's doing. The queries are obviously in the dashboard if you go see a view in RQL or in the edit mode, or if you want to change the behavior, it's all there. Yes. So if you clone the entire repository, it will download it all for you.
What is the repository name?
So the repository can be found. Where's the mouse? Here. Oh, it's not showing. There. So if you go there, this is just a, so you don't need to memorize the whole thing. This leads you to the GitHub repository. You clone the repository. You read the document, the README, which tells you take this file, change a few variables, run the Terraform plan, and apply eventually. So if you want to have a look at it later, the content is all there.
The thing is like we have a VPA and we tried it because we had the option to restart our containers.
Yep.
Because each API using a single container, so
Mm-hmm.
that's fine.
Mhm.
But still we are not getting the good expected result.
Yep.
Maybe, as you said, like, the way we are defining. So it's giving us like, some API is like more memory utilized and some
Mhm.
require more CPU. So based on that, we increase like whatever the recommendation, we actually increase like another 20% on top of that.
Yep.
And put it, but still it's not giving us
Mhm.
like good results. So
Yep.
that's why I wanted to try this.
Sure.
And VPA is also kind of like another extra load we are putting it into the clusters. So this is, I believe, nothing else. It's just
Give it a try. Also, you can, let's say, you run it once, let it be. A couple of weeks or months later, your application footprint may have changed as well. You added new functionalities, you stripped a few functions, whatever it is. Your applications change. You can have a look at the dashboard again and figure out, oh, I want to allocate more, I want to strip resources.
so this is not gonna be like an extra load to them.
Not at all. This is happening completely, exactly. The data for the dashboard is in your Relic anyway. So it's just a visualization of data that is already collected. No added cost, nothing. No install, it is just the dashboard.
But do you think I can directly implement it for machine?
Yeah, this can't break anything.
Yeah, because it's a Terraform file.
Yeah, it is just creating a dashboard. That's it. You can't break anything. Applying the changes, using the recommendations. This is something I would say, do it somewhere else first. In production, if you can do a canary deployment or something like that you can see, does my application work well? Or at least if you deploy it, observe it and see, does your application suffer? Is response times going up? Is error rate increasing? Do I see an out-of-memory kill more often? Because I can guarantee that nothing will ever happen because I don't know what your companies are all running.
Okay. Yeah, I'll try that.
Okay.
Main is like, we are not getting a good result. Whatever that we try, like VPA, we have the good dashboards,
Yeah.
more the transaction level things.
Yeah.
So we are actually using Portal
Mm-hmm.
to collect the
Yeah.
metrics and then
Yeah.
sending it. But Portal is also not that much, if you compare to the APM, right? So it's not
Yeah.
giving us good results.
So this uses only infrastructure metrics, nothing application specific, but yeah.
Yeah, but it's like so many things.
Mm-hmm. Okay. If it helps, please let me know.
Yes, yes.
Okay.
I'll just check.
Okay, cool. Thank you very much.